Hello, everyone, and welcome to today's Ask-a-Meteorologist. And it's an international Ask-a-Meteorologist. We've got students from all around the country joining us today. Let me introduce myself. My name is Tim Bryce. I'm a meteorologist with the National Weather Service in El Paso, Texas. That's in the far western corner of Texas. Joining me today is my co-partner in hanging out. He's also a forecaster here at the El Paso Weather Office, Jason Laney. How are you doing, Jason?
Hi, everybody. Good to see everyone. Bienvenidos para mis amigos en Sur y Centroamérica.
Very good. So like Jason just said, we've got a group of kids. This is Miss Miss Trevino's class down in Mexico. I believe it's in Monterrey. How are you guys? Looking good? Then this is Miss Dodge's class. They are in Poughkeepsie, New York. Thanks for joining us. Here's Miss Haas's class. And they are in, let me see if I can say it right, Plattekill, New York. Then we're down here with Miss Balin's class down in Buenos Aires. Hey guys, how are you all doing? And finally, our last class is Miss Ann and Miss Wagler. You guys are over in Norton, Ohio. Look at everybody there. You guys are looking good, looking good. Alrighty. So, you all are looking good. What we're going to do, we're going to try to give you a quick presentation. As you can kind of tell, me and Mr. Jason are not at work. We usually do these hangouts at work, but hey, Jason, is today your off day?
Yeah, today, believe it or not, is my day off from work. Although I've had several days off, I've been home sick for a couple of days. But I'm all better today.
I got to cover one of your shifts. But and that's the thing about the Weather Service, and we can talk about this if you guys have a question about it. But to work in the Weather Service, it's a 24/7 operation. So we have days off during the week. We have to work at midnight sometimes and on Christmas. So we have wacky work schedules. But I go into work tonight. I work 4 to midnight. Jason has the day off, but the important thing is that we get to join you and talk about the weather and answer your weather questions. So, teachers, so you understand how things will work today, Jason's going to give a short presentation, and then we're going to just open it up to questions. I've got everybody muted right now, so if you can, I will try to unmute you, but I'm pretty sure, Miss Vicky, you're going to have to help me, Miss Vicky's class is going to have to help me unmute your mics because I had to mute them a different way, and I'm not going to be able to unmute it manually. So when it comes to your turn, I'll let you know, and you can unmute that mic. We'll just go down. We'll have a student ready to ask a question. Jason and I will answer, and then we'll move on to the next student, and we'll just keep answering as many questions as we can before the hour runs out. So without further ado, I'm going to turn things over to Mr. Jason, who already has his presentation up on the screen.
Oh, yes. I wanted to show you guys exactly where I am located. Well, I'm not located here right now because I'm at work. But this is our office. This is the National Weather Service office in El Paso, Texas. And one of the neat things about our office is really where we're located. We're located in a desert. Now, I'm not sure. I've never been to Buenos Aires, but I think you've had plenty of rain here lately. And down in Monterey, maybe the same story. I know in the other parts of the United States you've had lots of rain, but in the desert we don't get much rain. And that's why we do our landscaping with rocks and the cactus out there. But it still makes for a nice, pretty place. So my next image should be coming up here momentarily. I thought it was going to come up. It looks like it's just going to a white screen. The next image was supposed to be a nice shot of our radar and where we are. Mr. Tim, I think that this thing is just completely frozen on me. So let me see if I can get back to my image. First of all, I'll let you guys see me there. So let me try one more time. You know how it is with computers. I think maybe it's time for me to invest in a better computer at my own house because this one doesn't seem to be doing the best job for me there. As a matter of fact, it's really, really slow. But let me try one more time, if you don't mind. I'm going to take you right back to my screen share here, and hopefully I'll be able to show you what it looks like. How do you like that? There we go. Now you can see my radar, can't you?
Yes.
That is the Doppler radar, and that's what we use to see storms when they're coming. And you can see the day I took this picture, it was a nice cloudy day out there. Now, we work for the National Weather Service. We're located right here in El Paso. It's far western parts of Texas. But we have 122 National Weather Service offices all around the United States. And for the students that are with us today, some of you get your weather reports from an office in Albany, others in New York, some in Cleveland. Now, I hate to say it, but we do not forecast the weather for Mexico or Argentina. Where we do forecast the weather for, we kind of keep a close eye on things. This is inside our office, and all of the offices look very similar. You can see one of the main things that we have are lots of computer monitors because there's just so much data to look at. Some of the things that we look at are satellite photographs that show us where the clouds are. And of course, this is a satellite photograph of the United States, but we have the ability to see satellite images all over the world. You see, weather is international. The same way with our radar. We have our own network of Doppler radars around the United States, like the one you saw at our office. And when we piece those together, we can see where the rain and the storms are. And right now, it's a little wet across the Great Lakes and just south of the folks up in New York and down along the Gulf Coast as well. But the thing that most of us can relate to is the temperature, right? So I plotted the temperatures from about an hour ago. And as you might expect, northern United States a little cooler. Southern United States warmer, even warmer as we get down into Mexico, Central America, and the equatorial regions of South America. And then as you go south of the equator, it begins to cool off little by little so that we're back in the 60s down in Argentina. Now, this makes complete sense to the students in the United States because these temperatures are in degrees Fahrenheit. But believe it or not, temperature is always reported in degrees centigrade. Not just in other parts of the world, but for meteorologists as well. We actually have to convert the temperatures before we show them to people here in the United States. So this is a look at the real temperature in degrees centigrade. 19 degrees in Arizona, 28 degrees in parts of Mexico, 30 in Venezuela, and 13 down in Buenos Aires right now. So you kind of have an idea of what the weather is like where you live. Now, when we put it all together, our job's not just to tell you what the weather is now, but what the weather is going to be. So this is a weather map for the United States for later today. We've got one storm right here over the Ohio River Valley, another storm over New Mexico and the Rocky Mountains. Now, if I go forward 24 hours into tomorrow, that first storm that was in the Ohio Valley, it's over here over the ocean. The storm that was in New Mexico is over Texas, and I think it's going to be a bad stormy day in parts of Texas tomorrow. And here comes a third storm across the northern Rockies. So there is just all kinds of weather to talk about out there. The weather happens so rapidly and it changes so rapidly, it really keeps us on our toes here as meteorologists with the National Weather Service. The same thing for the weather services down in South America, Central America. But just shows you a little of what we do each day. I'm sure you've got much more questions than I was even able to answer there. So, Mr. Tim, let's see if we can get some of those questions answered.
Very good. So what we're going to do now is we're going to start answering everyone's questions. I want to thank Jason for a great presentation. And it is interesting to see how we measure temperatures. Temperature's the same, but we use different units, whether it's Celsius or Fahrenheit. I've always found that interesting. So, teachers, we're going to start asking, having your students ask questions. And just help me unmute the mics when it's your turn to ask a question. And we'll go to Miss Trevino's class first in Mexico.
We are ready.
Perfect. Okay, who's got a question for us?
Okay, the first student is coming. Sit down. Loud, honey.
My name is Lucy, and I want to know if why
Ask your question.
why did you choose to be a meteorologist?
Why did I choose to be a meteorologist? I'm going to let Jason answer that first. Great question. We get it all the time because it is something that's cool, but you don't know a lot of people who are meteorologists. But Jason, why did you become a meteorologist?
Well, when I was about the same age as these students that we're talking to today, I grew up in a state called Mississippi. We had lots of thunderstorms. And back then we didn't have television and the internet like we have today. We had television, but we didn't have as many channels, okay? I'm not that old. But we had big storms, and every time there was a storm, there would be a sound. It was a very loud horn or siren, and it would go, whoa, and it would let us know that a tornado was nearby. And whenever that happened, I was so frightened. I was afraid of the weather. And I told myself, even when I was a young child, that if I was a meteorologist and I studied the weather and I understood it better, I wouldn't be so scared of it. So my interest in weather actually started originally because I was scared of it. But let me tell you, I'm not afraid of the weather anymore. It's afraid of me.
Ah, very good. Well, the reason I became a meteorologist is I grew up in Oklahoma, which is in the central part of the United States, and we get all kinds of very interesting weather. But I didn't originally want to be a meteorologist. Maybe you guys can learn a lesson from this. I went to school, I went to college to be a journalist, to be a TV reporter, but after doing that for a couple of years in classes and things, I found out that wasn't for me. So somebody suggested meteorology, and I'd always loved science and technology, so I took my intro to meteorology class, and it was like perfect. I loved it, and I went ahead and got a degree. It's a 4-year degree. You go to college for 4 years to get a degree in atmospheric science. And then I got a job with the National Weather Service. And I get to, like Jason showed you, we got all kinds of computers. So I get to play with all kinds of technology. I get to talk to kids like you all the time, all around the world about the weather. So I just love working with the Weather Service. I get to help people. I get to issue warnings and let people know when the bad weather's coming so that they can take action and protect their property, their house, their cars. They can get inside safe away from the bad weather. So I really love working, being a meteorologist because I get to help people and I get to play with computers and technology. So very good question. All right, so let's go over to Miss Dodge's class there in, I believe, you want me to guys? Okay, go ahead. You guys are unmuted.
We're unmuted? Okay. Oh, Carl, come on. Right here.
How do you know the strength of the storm?
Are you talking like a thunderstorm or a hurricane or a tornado?
Tornado.
A tornado? Well, that's a very good question because you can't really look at a tornado and see how strong it is. You can look at it and you can go, that looks pretty bad, that looks pretty wide. A lot of times you see that in Oklahoma. But you just can't look at a tornado and see the strength of it. But what we can do and what we do after a tornado is we send in a team of meteorologists. And they go and they look at the damage that the tornado did. And then they look at the damage and they compare it to some different things that they've seen. Jason's having trouble. I'm trying to get Jason's screen up here for everyone to see. We'll see if it shows up. Is it going to show up, Jason?
Let's try it one more time. I had a screen, but it looked just like you.
I know. I saw it too. Anyway, so what you do is you send out these survey teams, and they look at the damage, and then they can, based on the damage, they can tell how strong the tornado was, whether it blew over a mobile home, whether it just blew some shingles off the roof, and there you can see it's called the EF scale, and it goes from 0 to 5. EF0, you can see, is just like it tops out at 85 miles an hour. It would blow some shingles off the roof. Then as you jump down, you would see that maybe at an EF3, you're talking 150 mile an hour winds. That's where you're starting to take the roofs off of houses. And as you get even further down, EF4, EF5 is where you have wind speeds over 200 miles an hour. And basically that wipes that foundation of your house completely clear of all the debris. So basically, to tell the strength of a tornado, you really can't tell. You can look at a tornado and go, that's strong, but you don't know the exact wind speeds and how much damage it's doing until afterwards when you do go in, and we have teams that do surveys after the tornadoes. So we just had a round of tornadoes in the middle part of the United States a couple days ago. I think it was on Tuesday, and they've already sent out teams, and they found that we had, like, I think 6 tornadoes touch down in Oklahoma, Arkansas, Missouri, and places like that. But they were weak, but still they were tornadoes, and they can all do damage. I think I saw some damage up in Iowa as well. So very good question. All right, let's go to Ms. Haas's class, also in New York. Let me, I will get you unmuted, and, okay, go ahead. Coming up.
Why do we have weather?
Why do you have weather? It's a great question because that pays my bills. That's what keeps me employed. I love it. No, actually, I'm going to let Jason answer why do we have weather, because it's actually a very important process that keeps the Earth in balance. So go ahead, sir.
No doubt. First of all, let me tell you what weather is, okay? Weather is what is happening with the air around us at any given time and any particular place. For instance, right now I'm in El Paso, Texas. The air outside in El Paso, Texas is dry. It's moving pretty fast. It's a little windy. It's warm. The temperature is coming up quickly, and the skies are clear. We don't have any clouds. You see, that's what's happening right here, right now. So that is weather. That's what weather is by definition. But weather is always changing, and I think that's what really keeps Tim and I employed and busy on a daily basis. I like to say that weather is nature achieving a balance. Imagine if over here I've got air that's really, really hot, and over here I've got air that's really, really cold. Do you know what nature says? It says, I don't like this. One's too hot, one's too cold. So what it does, it begins to mix things up. It begins to move the air. It takes the hot air and brings it to the cold. It takes the cold air, brings it over to where the hot air was. And as the air begins to move, the weather begins to change. Sometimes it produces clouds, sometimes it produces storms. So my simple answer is weather is caused by nature trying to achieve a balance. It's never going to be balanced, is it, Mr. Tim?
No, it won't be.
It's going to be in motion trying to achieve it.
Yeah, so, you know, if you think about the sun is always shining the most on the equator, shining the least on the poles. So the poles would always be getting colder and colder and colder and colder, and the equator would keep getting hotter and hotter. If nothing changed, it would just keep getting hotter at the poles and colder, or hotter at the equator and colder at the poles. But because we do move the air, so the equator, we move the warm air away from the equator towards the poles, and at the poles we move that cold air towards the equator. I usually say when we're talking to our students in North America, I always say we're moving the warm air up from the south and moving the cold air down from the north. But our friends down in Buenos Aires, it's exactly the opposite. We're taking that warm air at the equator and you're moving it south, and you're taking that cold air at the poles and moving it north. It's amazing how it works the same all around the Earth. But basically, like Jason said, we're keeping that balance of those high and low temperatures. And speaking of our friends down in Buenos Aires, let's see who has a question there. Okay, go ahead.
Yeah. What is a typhoon? Where do they happen more frequently, and why?
So say the question again.
Yeah. What is a typhoon?
Gotcha.
Where it happens more?
And where it happens more often.
Right, so the question is, what is a typhoon and where do they happen more often? So that's a very good question. Typhoons is simply a different name for hurricanes. And we get hurricanes, typhoons, cyclones all around the world. They form either just north and south of the equator, and they form as an area of low pressure. And we mentioned low pressure and high pressure. You'll see that on weather maps. There'll be L's and H's in the United States. And I tell people that stands for low pressure is for lousy weather, and high pressure stands for happy weather. For those of you who are more familiar with Spanish, you'll see the A's and the B's on the weather maps, and that stands for alto y bajo. And Jason, what do you say? Have we figured out what to say for alto y bajo?
I figured out that alta presión is tiempo agradable. Baja presión is bastante mal.
Bastante mal. So basically, you get bad weather with low pressure, lousy weather, or bastante mal weather. So a hurricane or a cyclone is simply just a big area of low pressure, and it spins like a pinwheel. And what happens is that it uses that warm ocean water to be its fuel, and then it moves across the ocean staying with that warm ocean water. Now, if it moves over colder water, it gets weaker. If it moves inland, it is completely cut off from its food supply. I think you all like to eat food. We all like to have chicken and hamburgers. But if we don't eat breakfast, lunch, and dinner, the next day when we go to school, we don't want to go around and play and run and jump. We just want to go, oh, I'm so tired. Same thing happens if you cut off a hurricane from its fuel supply. It ends up getting weaker and weaker and weaker very quickly. So basically, whether you call it a typhoon, a cyclone, a hurricane, or even off the coast of Australia where they call it a willy willy, you end up, it's a big area of low pressure. It's actually hundreds of thunderstorms, and Mr. Jason likes to call it the greatest storm on earth because it can be as big as a state, one of the United States, and it can do a lot of damage, especially if you're right on the shore when it comes ashore. How does that sound, Jason?
I think you did a great job.
Very good. All right, so let's go back to Miss Ann's class. Not back. Let's see our first student there with a question. And let me find the... Oh, okay, very good. Go ahead. You guys are... No, go ahead.
This year's winter was very warm. This was caused by El Nino. What is El Nino and how does it work?
Very good. You are exactly correct. El Nino was the culprit for you guys across the northern part of the United States getting some warmer weather and not as much snow. What El Nino is I like to say it real quick. Are you guys ready? Is everyone ready? El Nino is an abnormal warming of the equatorial waters off the coast of Peru. That's a lot of words to say. What does it all mean? Basically, it just means that the waters off the coast of Peru, which is a country down in South America, stretching out into the Pacific Ocean, you know, that big ocean of water, they got warmer than normal. El Nino doesn't make weather, it just redistributes the weather. If you've got like a stream, you guys have all seen a stream or a creek going by, if you put a rock in the stream, the same amount of water goes by, it just goes by in a different pattern. So if you put a rock in the stream, the flow around that rock kind of goes in a different direction. El Nino is like that. It's like a big rock in the stream. So the storm's track that would have gone to the north is all of a sudden brought to the south. So for North America, during El Nino, it means for the northern part of the United States, it means it's going to be warmer than normal and drier than normal. For the southern part of the United States, it means it's going to be cooler than normal and it will be wetter than normal. And basically what happened, I know in El Paso, we were a little cooler than normal, but we ended up with a day when we had 10 inches of snow on the ground. And Jason's got a great graphic here of the El Nino. So you can see here is the equator. Show them the equator where it is. It's right there in the middle. It's right off. It runs between Australia and South America. And you can see that in El Nino, the waters get a little warmer, and it affects the circulation not only in the United States, but you can also see in Australia. They are drier than normal. When there's an El Nino, they end up with lots of fires, and it does affect the circulations in South America, in Central America, even in Mexico. So El Nino happens there on the equator between Australia and Peru, but it affects the weather all around the country. And specifically for Ohio, it gave you guys warmer than normal temperatures during the winter and a lot less snow than you're used to. I was talking with somebody from New York, in Binghamton, New York, and they said that they had only gotten like 20 inches of snow. And I said, oh my gosh, El Paso almost got more snow than Binghamton, New York. So very good question. So it's that abnormal warming. Doesn't create weather, just kind of moves it in different directions. Very good question. All right, let's go back to Ms. Trevino's class down in Mexico. And You can unmute it for me, please, ma'am.
There.
Awesome.
Okay. Let me turn it on. There.
Hi, my name is Paula, and my question is, how do you read weather maps? For example, the ones that have different colors in a hurricane.
Very good. So the question she asks is, how do we read weather maps? And I'm going to let Mr. Jason answer that question. Can you do that for me,
Oh,
Jason?
okay. I can do that. Well, first of all, when we look at our weather maps, there's several very important things that we want to see on the weather map. And they're all based on what we call observations. You have to imagine that not just in the United States, not just in Mexico, not just in South America, but all over the world, there are weather observations taken every day. It tells us how hot it is, how cold it is, whether the air's dry or moist, if the wind is moving, if it is moving, how fast it's moving, if it's raining, if it's cloudy, if it's sunny, all of these things. And we take and we put every one of those on a map so we can see what it looks like. And then we do what we call analyzing the map. We look for areas of high and low pressure or areas of alto y baja presión. That's really the key to weather, is the pressure, believe it or not. And then we have things associated with those that are called fronts, which is when cold air is moving in to take the place of warm air. We call that a cold front. Or when warm air is moving in to take cold air, we call that a warm front. So on our weather maps, cold fronts are always going to be blue. You ask about the color. Warm fronts are always going to be red. Now, when it comes to hurricanes, we usually plot hurricanes on a map with a very special symbol, and they are always drawn in red as well. And it turns out that the color red is one that kind of means danger. You'll probably notice if you're traveling in a car and you come to a traffic light or a semáforo, you have to stop when the light turns red. So here is a weather map that Mr. Tim has brought up for me, and you can see we have low pressures. We went ahead and wrote the word low on this to make it easy. We have high pressure. We put the words high on there. And you see those fronts that I was talking about, the warm fronts in red, the cold fronts in blue? Another thing that we draw on the weather map is areas where we think it's going to rain. And we associate the color green with rain. So we have different colors for all different things on the weather map. So after you've looked at a weather map long enough, you get really good at reading them. How about that? Those colors of the weather map look just like the colors in the flag in Mexico, the red, the white, and the green. We did that just for you guys, by the way.
Very good. Yeah, you look at weather maps and sometimes you see all those squiggly lines. It can be a little confusing. And sometimes we color all the temperatures, we color the whole map based on the color of the temperatures. You get big bands of color on there. So I can understand a lot of times it looks like spaghetti, or it can be very hard to just like someone spilled a bunch of paint on the map. But if you start to study them, you can see there's a pattern to it, and it helps us to better interpret the weather and helps you to better see the weather as you're going along. All right, let's go back over to Miss Dodge's class there. Go ahead.
How do you use a hygrometer or a barometer?
Very good question. So we'll have to define what those are. So you ask, how do we use a hygrometer or a barometer? And actually, we use a lot of tools. Those are the tools that we use to observe the weather. Great question, by the way. Those are our instruments that we use. You always want to know what's going on in the weather. So we take weather observations. You do that with instruments. One of those is a thermometer. When you get sick, your mom or dad takes your temperature with a thermometer. Well, we take the temperature of the air with a thermometer. We also want to keep track of how much moisture is in the air. And we use an instrument called a hygrometer. And it basically tells us how much moisture is in the air. And it takes several different forms. Did you know in the old days that they used to make a hygrometer out of human hair? Because human hair is very sensitive to humidity. It actually gets longer when there's humidity, and it gets shorter when it's drier. And they would have some human hair, and as it would get drier, it would pull to get a little closer, and it would make the pen on the sheet go up and down. So we measure, that's one kind of hygrometer. These days, we don't use human hair anymore. It's an electronic kind of device. Mr. Jason has some maps or a picture of all of these. So here's the map here. So I got a thermometer was the first one. The next one there in the middle is called an anemometer, and it helps us to measure the wind speed. And as those little cups spin around, you see it measures how quickly the wind is spinning. Then next to it is that hygrometer, measures the humidity or the moisture in the air. On the bottom row, we have something called a rain gauge. It just simply measures how much rain has fallen. Lets us know if it was a lot of rain or a little bit of rain. Then next to that is the wind vane. That lets us know which direction the wind is blowing. And then next to that one is a snow gauge. Basically measures how much snow falls. So we're able to take all these different instruments, and of course, knowing the weather, knowing the temperature, the relative humidity, and we didn't have the barometer on there, did we, Jason?
I don't think the barometer made that one.
That's okay. I'll explain to you. A barometer is just another instrument, and it measures the air pressure. The air is made of oxygen and nitrogen molecules and a couple other ones, and they're always bouncing around, and they're bouncing off of us, bouncing off the walls and things. And as they bounce around, they exert pressure. We don't feel it because they're hitting us from all different directions. But the atmosphere is always pushing on us. As a matter of fact, we mentioned it, it's those areas of high pressure and low pressure, alto presión y bajo presión, that you end up with the different kinds of weather. And like I said, the lousy weather comes with the low pressure, and the happy weather comes with the high pressure. So we're always keeping track. Actually, the barometer is one of the most important tools that we do use, because as the barometer starts to get lower and lower, like it will in El Paso, Texas today, because it's sunny now, but I know by this afternoon it's going to get very, very windy because we've got an area of low pressure developing. So as the pressure goes down, many times you get that lousy weather, and as the pressure rises, you get the happier weather, and we need to track that, and one of the ways we do that is with the barometer. So we track pressure with a barometer and humidity with a hygrometer. So very good question. All right, let's go back over to our friends up in Plattekill, New York with Miss Haas's class. See, and you guys are unmuted.
Why do the clouds turn black when it's about to rain?
Very good question. They are mad. That's why they get very, very angry. Hey, Jason, why do clouds turn black when it's about to rain?
Well, it depends on which side of the cloud you're on as to whether it turns black. When a cloud gets ready to produce rain, that means the cloud is completely full of moisture and these big droplets of water ready to come down. You see, when clouds first start to form, they form when little tiny invisible droplets of water condensate and turn into liquid water droplets. These things are so tiny. Would you believe that it takes about 1 million cloud drops to make one raindrop? That's true. About 1 million cloud drops to make one raindrop. So when you just have a basic cloud up there with all those little teeny tiny little drops, what's happening? The light coming from the sun, we call that white light, is just kind of bouncing off of them and moving all directions, and we see reflections of light with our eyes. That's why clouds look white to us, because they little tiny drops of water and ice in the cloud just reflect the white light from the sun. But when that cloud gets full of those bigger droplets, those big giant droplets, 1 million cloud droplets in one, that causes them to become heavier and heavier. And it's like trying to look through a window with the shade closed. These clouds are so thick and the water droplets are so big that they're no longer reflecting the sun's light to our eyes, but they're blocking them out. So on the bottom side of the cloud right here, it looks all dark and gray and black and stormy. However, if you were an airplane flying over the top of this cloud, it would be as bright and puffy white as a cotton ball right now. So it's because the water droplets in a rain cloud are so much bigger that they block out the incoming sunlight. It's actually pretty simple when you think about it, but that's an easy way to know the weather. Isn't it amazing that you have observed when the sky gets dark, you know it's going to rain? Every day I make a mistake. At sunset I say, hey, it's going to rain, and oh no, it's wrong time of day. Sorry.
No, but that does bring up a good point, that you can kind of you don't even have to have a degree in meteorology. You can be your own weather person. You can be a weather forecaster by just looking out the window And you can see when it gets real dark and those clouds are coming, you know that there's probably a good chance of rain. Good question. All right, let's go back to our friends down in Buenos Aires. Go ahead and unmute it. And who's got a question there?
Why doesn't it snow more in Buenos Aires?
Go ahead and say that again.
Again.
Why doesn't it snow more in Buenos Aires?
Why doesn't it snow more in Buenos Aires?
Oh! Why doesn't it snow more in Buenos Aires? Because of the ocean, I assume, is very close to you guys. Is that right, Mr.?
See, go ahead. That's exactly right. Go ahead and pull up Google Maps if you will, right quick, and kind of zoom in for me, Mr. Tim. And I'll kind of explain this phenomena that's going on there. We have the same thing happen in the United States as well. For instance, you've probably heard of New York City, especially the people that live in New York. You've heard of it. Well, New York City does get snow from time to time, but it doesn't get as much snow as, say, Buffalo, New York does, and other places. And that's because New York City is right there beside the ocean. We like to say that the land gets colder quicker than water does. That's why it can be below freezing, but the water has not turned to ice yet. And it turns out that where New York City is located, where Washington, D.C. is located, where Buenos Aires is located, even though the temperatures get cold enough for snow, a lot of times your moisture comes in off of the nearby Atlantic Ocean, and not just the ocean, but that little body of water, that bay that comes inland as well, and that begins to moderate the air. If you live just a little further away from the coast, say maybe 250 kilometers, you would probably see a lot more snow than you do there in Buenos Aires. So it's something that doesn't just happen in your part of the world. It happens in many countries, including the United States, and it is the influence of the ocean. Now, sometimes that can work against us. If we get a cold enough storm, it can turn into an ice storm or a big snowstorm. But many times the ocean kind of stops it altogether. Mr. Tim, we never saw your map, but that's okay. Let's get to our next question.
There it is. I finally got it. I'm a little slow.
Oh my goodness.
You can see
Well,
that.
everybody take a look at our map. We now see Buenos Aires. Now, Mr. Tim, the million-dollar question for you. We need to know your geography. That body of water that's right beside Buenos Aires. What is the name of that body of water?
Good question.
You will get a 100% A-plus score of 10 if you get that correct.
I don't know. I'm going to have to say I don't know. I know that it leads out to the Atlantic Ocean.
Right. Okay, let's ask our students. This was Ask-a-Meteorologist, but let's ask the students. Students, can you tell us the name of that body of water?
Can you tell us the name of the water? What's the river called? In English.
Rio de la Plata. It's called the Rio de la Plata, but actually, while it is a rio, which is river for our friends in the United States, that has to be one of the biggest bodies of water I have ever seen, known as a river. And they call it a river because actually it is fresh water that's coming out of the higher terrain there to the north and west and flowing into the ocean. And with it being fresh water, if it weren't moving out towards the ocean, if it were just kind of sitting there, it would become all salty like the sea, and then it would actually be considered more of a bay like you have in San Francisco or the Chesapeake Bay up in the United States. Nice little geography lesson there. Thank you guys for sharing the name of your river that we like to call almost an ocean. Anything that big's an ocean to us in El Paso because we don't have any water here.
That's true. All right, let's go back to our friends over in Ohio.
Are dust devils and tornadoes the same?
Dust devils and tornadoes, are they the same? Great question. I like to tell people that dust devils and tornadoes are like cousins. You've got cousins, they're kind of in the same family, but they're not the same. A tornado starts in the cloud and works its way down to the ground and can actually, as we've seen, get very, very strong. Whereas a dust devil usually starts at the ground and works its way up into the sky. usually happens on warm, sunny days. So they're the same kind of rotating column of air, but they are caused by two different things. Basically, the atmosphere is always trying to get things in balance, and what's called is a momentum balance. I know that's kind of a big word, but here you can see kind of how a thunderstorm works, and it's always pulling up. Inside the thunderstorm, there's air moving up, there's air moving down, and sometimes that air gets swirling around inside the thunderstorm, and you end up, you guys have all seen the ice skater in the Olympics when she's skating around, and she's got her arms way out, she spins slow, and then as she pulls those arms in, she goes faster and faster and faster. Same thing happens in the thunderstorm when you're getting a tornado. The whole thunderstorm starts to rotate, and as inside the storm, as that rotation gets tighter and tighter, you end up with a tornado, and it drops out the bottom of the parent thunderstorm and comes down to the ground. Whereas on the earth, where it gets warm, you end up with some swirling air, and if it kind of gets a little organized on a warm, sunny day, which can happen, you end up with kind of a dust devil that forms, and sometimes they can actually get to be a couple thousand feet tall. Every once in a while, you get a dust devil that gets actually pulled into a tornado or a thunderstorm, and we end up calling those landspouts and gustnadoes. So you can get all kinds of things, and then you can get the same kind of phenomenon happening out over the ocean, and we call those water spouts. So we have all kinds of rotating columns of air. It's not just dust devils, it's not just tornadoes, but those are the two most common, are those dust devils and those tornadoes. All right, let's go back over.
Hey, I've got something I want to share.
You betcha, go ahead.
Mr. Tim, I just want to share something right here I thought was very interesting. I found this image, and hopefully you guys can see it on my screen there. This is actually where tornadoes occur around the entire world. Can you believe that? Now, obviously, we get lots of tornadoes in the United States. Any of these areas that you see on my map here that are colored in kind of this orange, that's where tornadoes are known to occur. And I find it interesting that northern Mexico tends to have tornadoes, but down into central and southern Mexico, they're not as common. And then you get down here into Argentina. Take a look at Argentina and Uruguay. Both of those areas are known to have tornadoes as well. So it's kind of interesting that we had the question about tornadoes coming from one of our students here in the United States, when actually, believe it or not, your friends that you're visiting with today down here in, or down there in Argentina, they actually have tornadoes as well. Isn't that cool, Mr. Tim?
It's cool. I've never seen that map before. That's a great find. All right, let's go back over to Mr. Nino's class there in the
Ready.
Perfect.
I want to know how can we take care of ourselves when there's a tornado.
Oh, how to take care of it when there is a tornado? Very good question. So, kind of what is the safety procedure for when we have a tornado? And that's very important if you, because you don't want to try to figure out, if someone says, hey, there's a tornado coming, you got 5 minutes, you don't want to run around and try to figure out what to do. You want to have a plan ahead of time. And in America, what we tell people to do, and it's the same thing no matter where you are, matter of fact, around the world, is that you need to find a safe place. And usually, most of the time, we are at home when there's a tornado, so we tell people to go to the lowest floor of their house, whether it's the first floor or the basement, and get away from the outside walls and windows. So in our house here in El Paso, we don't have tornadoes, but I do have a bathroom right in the middle of the house. It doesn't have any windows, and actually a bathroom is great because there's the water pipes in the walls, which also help protect you. And we tell people to go into the bathroom or a central closet or something that gets you away from the walls, and then you just have to wait there. If you want to be extra safe, make sure that you have a helmet on, because a lot of times in the very strong tornadoes, there can be lots of debris flying around. Make sure you have shoes that have a hard sole on them. So if there is a tornado damage, if you have to come out, you don't walk around and step on broken glass and nails and things. So it's just best to, when you hear the report of a tornado, is to go into a sturdy building, the first floor, the basement, if you've got one, in the central part of the building so that you can avoid any of the tornado damage. And if you do that, you will be safe from 99.9% of the tornadoes. How's that sound, Mr. Jason?
Very good. You've covered all the grounds. Remember that most people get hurt in tornadoes not because of the tornado itself, but because the tornado takes sticks and rocks and it throws them through the air at speeds of 100 to 200 miles an hour. And it's actually getting hit by what we call flying debris that can really do damage to people, even if you're not right in the middle of a tornado. So that's why we always say, get away from the windows, because windows break easily. But a lot of times the cement and the brick walls, they tend to hold up better.
All right, let's go back to our friends there in Poughkeepsie. Who's got a question there for us?
Yep, she's coming.
Very good.
How do warm and cold fronts form?
How do warm and cold fronts form? That's a very good question, because that's what gives us some of our most interesting weather. Jason, would you mind if I answer this one?
I would love for you to answer that one.
Okay. So basically, we mentioned it, we touched on it earlier, that the Earth is always trying to keep things in balance. So what happens is the sun shines the most, the brightest on the equator, which starts to warm up the equator, and it shines the least on the poles, and they start to get colder. And if nothing changed, the poles would keep getting colder and colder and colder, and the equator would keep getting warmer and warmer. But the Earth tries to keep things in balance, so we try to move that warm air away from the equator, and we try to move the cold air away from the poles towards the equator. So as that cold air in North America, what happens is that as that cold air sinks out of the Arctic, it forms a front, and it forms a nice sharp edge of where that cold air is. And you see that on the weather maps. On any weather map you look at, you'll see a cold front is that blue line with the blue triangles. And basically, as that cold air advances forward, and sometimes it's going south, sometimes it's going east, and you will see, and every once in a while you'll see it going west. So you'll see that cold air, and the cold air is just replacing the warm air. The opposite kind of happens as we're moving that warm air away from the equator and towards the poles. You will see the warm front, and that's that red line on the weather map with the half circles. And the way the half circles are pointing is the direction of the warm front is moving. So basically, the warm air is replacing the cooler air that it's running up against. That cold front gives you your most vigorous and interesting weather. That's where you get some real powerful thunderstorms. Excuse me. And you can actually, once you get a thunderstorm going, then you can get your hail and your tornadoes, your big strong winds. I know that in North America, that's where we get our most vigorous weather. It's right along those cold fronts. And you'll see that happening later today and tomorrow, like we did earlier in the week. But basically, Mr. Jason has a map up here, shows you all the different kind of air masses, and this one is centered on North America, but the same thing happens on the southern hemisphere as well. You'll have air masses that form over the oceans, and they're warm and moist. You'll have air masses that form over the land, especially up north, and they're cold and dry, and those are called continental polar. And as those cold continental polar air masses drop down out of the Arctic, you get that front right along the front edge. And like I said, right where the front is, right where that cold air is replacing the warm air, is where you end up with that cold front. So very good question there. And we see those, and you can see those on the weather map all of the time. Let's go back over to Ms. Haas's class. They're also in New York. Let me unmute you guys. Okay, go ahead.
How do you know if it is going to snow, blizzard, or hail?
How do we know is if it's going to snow, blizzard, or hail? Those are all kind of icy things that fall out of the atmosphere. Jason, how do they know whether it's going to?
Well, a lot of it has to do with exactly what the entire makeup of the atmosphere is doing right now. Hopefully you'll be able to find that little image, Mr. Tim, of the cross-section. I don't have it with me today, but let's think about it. If the air is cold from the top to the bottom, and I mean cold, I mean below 32 Fahrenheit or below 0 degrees Celsius. If it is below freezing, that means no matter whether you're way up in the top of the cloud, at the bottom of the cloud, or down at the ground, anything that comes our way is going to be frozen. That usually means we're going to have snow. And the way we know the temperatures top to bottom is we send up weather balloons. Now, you ask if we're going to have a blizzard versus snow. Well, blizzards are caused because of the wind. First, you have to have the snow, because once you get the snow, it can either be snowing now, or it could have snowed yesterday and the snow is still left over. Then when the big winds blow, it creates visibility that we can't see, so that's a blizzard. So the difference between snow and blizzard is whether we have the wind or not. If we have the strong winds, we'll get the blizzard. Without the wind, it's just snow. And then we have some other wintry precipitation that Mr. Tim is showing us. One of them is called sleet. And actually, this is because at the clouds, it's always snow. Look across the top up there. All those snowflakes. But see that area that's colored yellow? That's warm air that our weather balloon found when it went up above the ground. And if the snow falls into warm air, it turns into rain droplets. But then if those rain droplets turn back into ice before they hit the ground, we call that sleet. If they stay liquid and turn into ice after hitting the ground, we call that freezing rain. And of course, if it never does freeze or it's above freezing, we just get rain. So that's winter precipitation: snow, sleet, freezing rain, and rainfall there. It has to do with the temperature of the air above us, as there's some warm air there. But hail is a completely different story. You want to talk about hail, and I'll find you a nice little image, Mr. Tim.
You betcha. So hail starts in a thunderstorm cloud. I think of some of these thunderstorm clouds as like a big juggler. And what it does is it starts juggling these balls of hail. And most of the time, the hail is pretty small. It's pea-sized hail. But what happens is that the winds inside the thunderstorm, if they're strong enough, they will blow that little pea-sized hail back up into the top part of the thunderstorm, and it starts getting ice. You saw on the other map I just showed how you get moisture kind of wraps around it and gets kind of coated with moisture, gets colder, gets frozen, and then it kind of gets heavier and it starts to fall down, and then the wind will pick it back up and throw it back up. So imagine a juggler. As long as he's a strong juggler, he can keep those balls of ice in the air for a longer period of time, but eventually the ball of ice gets stronger than the wind gusts inside the thunderstorm, and it falls out the side of the thunderstorm, out of the bottom of the thunderstorm, and you end up with a big chunk of ice falling out of the sky. Now, if the wind inside the thunderstorm is weak, you get a little tiny one, the pea-sized one. But if it's very strong winds inside the thunderstorm, you'll get hail the size of golf balls, even baseballs, and on rare occasions, and I saw it just last week, you get some softball-sized hail. So out of these clouds, you can get all kinds of different weather. It just depends on sometimes the time of year, depends on the temperature, whether you get, if it's summer, you get hail. If it's winter, you'll get more of the frozen snow and sleet. But it all depends on the structure of the atmosphere, and like Mr. Jason said, is it warm, is it cold, and how deep is that cold layer in that warm layer? Very good question. Let's go back to our friends down in Buenos Aires. Who's got a question there, guys? I think you guys are muted still.
We will throw out that, by the way, when we were talking of the hail, we were talking about something called granizo for our friends down in Central and South America. The granizo.
Okay, who's got a question down there in Buenos Aires?
Hi, my name is Lucas, and I want to know how the waves originate.
Waves.
Go ahead and repeat the question.
Again.
How do waves originate?
How does the weather originate? Was that my question?
No, the waves.
Oh, how do the waves? The olas, the waves in the ocean, how do they originate? Very good. Mr. Tim, it has to do with the wind, doesn't it, and pressure?
It does. Actually, there's a lot of things, because the Earth is a big system, and you've got the atmosphere, and you've got the ocean, and they seem like they're separate, but they actually affect each other on a regular basis. And like Mr. Jason said, the wind blowing sometimes can actually give you those waves. Now we've seen how the ocean goes up or down, and you get especially if you live near the ocean every day, you'll see the tide, and the waves come a little further into the land and a little further. And of course, that's caused by the moon. But the waves themselves start way out of the ocean. They start with the wind, and as it blows across the ocean, it starts to pile up those waves. If you get a big storm out in the ocean, you'll get even bigger waves. And I've seen that you have like a hurricane or a cyclone or a typhoon way off coast, you can get what they call the swells or the big waves associated with that storm that will travel hundreds of miles, and you'll get big waves crashing into the shore. So yeah, basically it's the waves starting off with the wind blowing on the ocean water, so the atmosphere affects the ocean. Of course, the ocean can affect the atmosphere too. A lot of that water vapor can go, like we mentioned earlier, can go up into the atmosphere and fuel those hurricanes. So it's a system that works very close together, and it's very tied together. But basically, those winds will blow on the ocean and give you the waves. How's that sound, Mr. Jason?
Sounds pretty good. I was trying to get a nice little image up here, but I don't know if I can screen share it. I apologize, everybody, for not going to work on my day off, because if I had been at work, I could have had all kind of cool things. One last thing to notice about the waves, though, if you've ever been out in the ocean, if you've been on a boat, and I know you folks that are down in Buenos Aires, you have a chance to do that from time to time. If you're further out in the ocean, it seems that the waves aren't as big unless it's a major storm, right? But when you're standing on the beach in La Playa, you notice that the waves seem to get bigger and bigger. Lots of people like to go surfing on those waves. Well, it's because of the amount of water. If you have this much water in an ocean this deep moving across the ocean, even slowly, then all of a sudden the ocean gets more shallow. That causes the volume of water to lift. So that's why you always get the large breaking waves at the coast, and you don't see them far out in the middle of the ocean. It has to do with the change of how deep the ocean is as you get closer to the coast. That's a pretty good question.
That is.
I think we have time for one more question before our time runs out, Mr. Tim.
That's true. So let's go back to our friends in Ohio.
Why does it get darker early in the winter?
Oh, why does it get darker earlier in the winter? Very good question. Jason, can you answer that for us? I'll see if
I can. Mr. Tim, if you have access to our weather basic slides, I don't have them here with me today. There's something I want to show you. You ask, why does it get dark so early in the winter? You've probably noticed that in the summertime the days are nice and long, and then in the wintertime they get shorter and shorter. How can that be? It's the same sun, right? Well, that's right. But did you know that the Earth is nice and round, right? It has a point at the top called the North Pole, a point at the bottom called the South Pole, and that little imaginary axis that runs between the North and South Pole is what the Earth spins on. And that axis is not straight up and down with respect to the sun. Would you believe that our Earth is actually tilted a little bit? It's tilted at 23.5 degrees. Not straight up and down, but it's leaning a little bit to the side. So as you can see my face, I don't know if you pay close attention to my face here, but I'm sitting in front of a window over here. You see how this side of my face is much brighter than this side over here? One is in the sunlight, the other is in the shade. Well, imagine that my big giant head is the globe. It's the world. And right now, half of my head is illuminated, the other half is in shadows. But if I tilt my head towards the sun, all of a sudden, more and more of my face is becoming illuminated and less of it gets dark. That would be the summer. But if I tilt my head away from that window, do you see how the top of my head is now going dark? And down here at the bottom is where all the light is shining? Well, that happens to us on the Earth. Whenever we're tilted towards the sun, that means we're nice and bright and we get more daylight hours. But when we're tilted away from the sun, then we're actually getting less daylight hours. And that's exactly why we have the seasons that we have. We have in the northern hemisphere, north of the equator, when it is summer and the days are long. In the southern hemisphere, it is going to be winter and the days short. So the simple answer is, I'm sorry we didn't get all of our images up because our computers are slower than we are today, but it's because the Earth is tilted on its axis.
Very true. So for us in North America, we are in springtime heading into the summer, but for our friends down in Buenos Aires, it's the opposite. They are headed into fall, or they're in fall, headed into winter. It's going to start getting colder down there on a regular basis, but we're starting to get warmer on a regular basis. Well, I want to thank everybody for joining us today. We had a fun time with all the students all around the world from Buenos Aires. I'm glad you guys could join us from Mexico and from all around the country. Let me turn on everyone's mic so we can say goodbye to everybody, but I do want to thank everybody who was able to join us. So here's Miss Vicky's class in Mexico. Bye, guys. Thanks for joining us. There's our friends in New York. Bye, guys. There's our other friends in New York. You guys did. Here's our friend down in Buenos Aires. Thank you guys for joining us. And our friends in Ohio. You guys did a question. Thank you so much for joining us today.
Just move the mouse. It's okay.
A lot of fun. Thank you guys. It's been
There we
great.
go.
Teachers, just so you know,
There we go.
I'm sending you a link to the presentation later today when I get to work, and I'll send you some of the slides that we weren't able to show you guys. So again, I apologize I'm not getting to show you all the slides, but I'll send you a link. I'll send you the presentation so you can look at all the slides and share them with your students. So I really appreciate everyone joining us today. Have a great day and enjoy the weather.
Bye-bye.